All right. Hello, everybody. So welcome back, and we're gonna jump right into the materials of the discussion. So yes, to recap so far that we have learned, we learned all the algorithm that we learned. We learned something that's called supervised learning, right? And for the supervised learning, typically you're given a label or given a true value of the data, right? And then so that we can modify your algorithm, your model, your machine learning model, right? But there's also another area which is unsupervised learning, and this one its label is not given, right? So typically you have all kinds of maybe data clustering, right? And then you would have to, from the goal for this unsupervised learning is to let the computer do some kind of algorithm uh, to kind of group the data by itself so that when we input the new test data, we can kind of see like which data that belongs to. Kind of like how you do the some kind of like recommending system, right? You would say if one person like one thing, another, and there's a two group like group one, group two, right? And then if you goes in and say, oh, this my data is kind of belong in the group one, so then you can also explore more data inside of here, right? That's also part of the unsupervised learning. And there are three main algorithms that should be covered in the lecture, but I don't think you need to like fully understand, memorize the how it works. You just kind of know the whole purpose of you can do something along these three algorithms to classify the data and group the data all together. All right. So let's work on the first algorithm, which is the k-means clustering. Right? So k-means is the k is basically the number for you to choose, right? So that you can kind of group them by that k groups. So this one gonna be number, and basically you use them finding the means or finding the average, and then you clustering them together. So let's suppose that we set the k is equal to 2 in this case for this example, and the way k-means algorithm works is that first, it initializes the position of clustering randomly. So suppose say you have this position for the blue one for the first class, and then the second one is this X, right? And for every point, every data point, you basically try to find which, find the minimum position or find the closest center of the clustering, and assign that data to to the center of the clustering. So for example, if you look into this data, right, you can kind of see that the position from here to the blue is uh, closer to the red. So you basically assign this one as a blue, right? So then you also keep repeating again, you compare it, and then you assign it. So this one could go here. So suppose like you can also compare it and then assign it, and then repeat it again and again, right? So then suppose this one also have closer one, so if assign this is blue, and then same thing, everything else will be red, but I'm just gonna skip the comparing distance position, right? Right. And then once you've done that and you assign the class, right, you also finding the means or the average position of all the clustered of all the data and its own class. So like you can see from the blue one, is you could go with the you would reassign the center to the main position of the new data set. So which is this, right? So it could be somewhere around maybe this point, right? So we'll remove this, the old one, and then same thing with the uh, red class too. So you have all this one, but then the data tend to cluster to the right side. So then you just assign it as X and around at this point, right? And then you remove all the label, right? And basically repeating defining minimum distance and the closest centroid between the data and the center, right? So again, so you keep doing comparing this one with the red, and then just assign it to the closest one. So this will goes into the blue, right? And this will go into the red because these are closer to the red rather than the blue, right? And then repeating by finding the average position and then reposition that center. So this blue one is gonna go here, probably like at here, right? And then the red one is also probably goes like here, right?
Wait, when setting up those k values, when programming them in, will you actually have to put in the coordinates for each of them, or will you just use like a random coordinate for each of them?
Yeah. Generally, it will be random because you also don't have the yeah, generally you just randomly pick any position. But yeah, we can also explore some kind of problem with random position and something like that too. But yeah, that's a good question. And the answer is yes, we just randomly assign position from the beginning. And then with the whole algorithm is going to kind of shift the center of the cluster to the hopefully ideal grouping or clustering.
Okay, I see.
Yeah.
So in the majority of cases, we'll randomly assign the k values,
Right.
k coordinates. Okay.
Yeah.
Okay, thank you.
Cool. Yeah, and then we keep repeating again, right? And you kind of see. So to resume, we reassign the new position, right? And then you just kind of also redo it again. But you can kind of see that if you redo it again, like you're gonna reassign all these data as a blue, and then all these data as red, right? So it means that our algorithm already converges, means that it already get into the best position for these two clustering. So you kind of stop there and then basically say that, okay, now we already splitting the data into these two class already. And then once you have a new data, like here, right, you can just gonna say, oh, then this one is gonna basically assign it to the red class because it's closer to the centroid, etc., etc. And this is going to be the work for how we use unsupervised algorithm to make a group of data. And yes, there's going to be some issue with as also Neil discussed, like we choose K. One is first, so there are two main problems, right? You have to pick the right K, and that's also how do you know the position is like uh, randomly initialized at the correct position. So we can work within like the 2D example to show it more concrete. So for example, you have the data that looks something like this, right? And just a 2D data. So something like here and maybe here. Right. Supposedly that you suppose that you decide to have the K is equal to 2, right? There could also be a case that if you repeat the whole algorithm again, and you choose K is equal to 2 for this example. So let me also split up. It could, in theory, split into these two, right? Into these two groups, since we split it at K is equal to 2, right? But if you look at the data, technically we kind of see that it should be classified into 3 groups, right? So this could be, yes, the red one is the first one, and then the second one should be this, right? And then the third one is supposed to be this, right? So then that's gonna be the work for you to keep changing K into different uh, different different value. So in this case you want to change it K to 3, right? And that will give you kind of better solution for you. And how do you know that that's give you a better solution? Typically, you can just look at the, I think the definition of it is something called variation. So let's see, like if you come back to a case of k is equal to 2, right? You're gonna see that the distance for this one, let me do that. The distance from the red and blue, right? So like the whole area of the red and blue is kind of unbalanced, right? It's kind of imbalance. It's like red is slightly greater than blue. But if you're repeating the example with k is equal to 3, let me get that. And you're gonna get something like this. So this one is also one group, and maybe purple is another group, right? You're gonna get the distance of its clustering to be almost equal to each other. This is just for this example, right? But yeah, the data could look different. And then when you kind of compare the distance of the group, this one is a variation. You can see that the value for the k is equal to 3 has a supposedly better, well, maybe it's just say subjectively better. You can also counter argue that too. Then, and you can see that the variation for k is equal to 3 is has the kind of similar value for each group rather than just k when you said k equal to 2 and then you have like this one slightly shorter and this one slightly longer. Right? So then you would have to, yes, so the whole goal of this is, yeah, you basically try to search for also many for different value of k, and then you do some kind of calculation to see if which one will works as your ideal group for you. But generally, yeah, but it also comes back to the unsupervised, which is that unsupervised learning, which is the whole idea of like letting the computer choose by itself. So so would you argue that 3 is better than 2, but supposedly like if if the case of 2 is also become something like this. This is also for 2, right? And this is also for 2. And you also get the distance or variation that looks something like this, right? Right, and then when you kind of compare the variation together, they also have the similar distance, and then k is equal to 3 also have the similar distance. So is that a right answer for you? Maybe the third one, but sometimes the k is equal to 2 also works for you, so you might have to. I don't have the full uh, measurement of how can you use it. Maybe I can also give you the resource, so maybe you can look up later too. But yeah, but the point is that there could be a different multiple correct solution, right? And this is like the problem of different k, right? But another issue is that yeah, we can also come into the issue of let me also get that new page, which is random initial point, right? Or I should say center. So yeah, so let's also look at this example. Copy that and that. So yeah, there's also a different. So there's also some issue with like when you randomly initialize the cluster point, right? So for example, you randomly cluster the red one to the very, very left, right? And then the blue one is kind of this point, right? So basically you just assign all these 5 to your blue and then assign this one to the red, right? And then you, in the algorithm, you also shift the position of the mean to the mean position. So it's going to be here, right? And then the blue is already converged to itself, right? And then you reassign the position to be something like, so then you reassign the position of the data to the closest cluster centroid, so it's our center, so it should be this, right? And readjust the mean to the mean update, right? And it will converge to something like this. So because if you redo it again, you're gonna see like this position to here is closer than to the left one, right? But and but yeah, as we also work on the example earlier, that's the case. There's also a case of maybe it will. I will skip the whole algorithm and then it will converge to something like this, like red one here and then blue. The blue group is here, right? And yes, we also gonna use the concept of variation and basically how spread of the data as our measurement to see which uh, which clustering position should be an ideal position, an ideal model for us. So like this one, you can see like the distance of the red and blue is quite different from each other, right? While the second case, if you like pick the right one, you're gonna get kind of similar distance, right? And basically, when you choose a K, you would have to you don't do the algorithm once. You would have to repeat it again and again to just so that you compare the different initial position and then only pick the best one that has the a good variation, which is you have a good spread. I would say like the spreadness of the data to be equal to another cluster. Yeah, that's so this one that's another issue with the k-mean algorithm and how you can work with it.
Wait, so the variation depends on the length of each like section of that we section it off into.
Yeah, so basically it's kind of it's basically the length of how each cluster is at the moment. Yeah.
Mm-hmm.
So
Okay.
also
So
the
like the
same thing.
first example that you're given right here, the first one, that would be a bad version of it because the two clusters are differing a lot in variation size. So
Right.
however, the second one would be a better one. Okay, I see that.
Yeah, exactly.
Okay, thank you.
Yep, no problem. But yeah, but if you also like be aware of the big picture, you can kind of see that the data can also be becomes a 3 cluster instead of 2, right? So that also falls back into the first problem that we also addressed, which is we also pick a different K and then try to see the variation and then do all the measurement by which I'll be honest, I don't remember off the top of my head at the moment. I think there's a measurement to see for which K is the best for you. But yeah, that's like the first algorithm for unsupervised learning on how you can classify the data by grouping unlabeled data together. And then we can have the second one, which is hierarchical. Do I spell it correctly? Let me double check. Is there C-H-I? Yeah, hierarchical clustering. And this one is basically you try to group the whole algorithm is that you basically group the similar data or maybe group the closest data all together, and you basically grouping them out and then find find, you keep grouping until you're getting a larger, right, and larger group, and then you find a cutting point so that you split the data into two groups. So for example, here, right, this one uh, uh, I kind of use it from the YouTube website, but YouTube channel. I can also link you guys into the uh, video too. I'll put that into the chat, and in case that you guys also want to look into full detail of it. And the first one is the K-mean clustering for the YouTube video, and the second one, I'll get that in a bit. This second one is also the hierarchical clustering, right? And yeah, I'll do the condensed version for the video, which is you basically group them together, right? You compare the first data with other data and see which one is has the similar data with. So let's like say this one gene one is quite, they have a red for the first column, and then also like a pink for the second column, and then the blue for the third column. So you see that gene 3 is also similar to gene 1. So basically you then group them together. You have something like this. This is the first group, right? And then same thing with the other genes. So this one also for second one, and the fourth one, then you group them up together, right? And then you keep grouping until you get the full cluster. But when you're doing the clustering, you then pick a point to kind of stop doing the clustering, and then you basically split them up. So for example, let me see if I can like expand it from here. Maybe I could go with this. So say you have data that looks something like this, right? This is also another representation of data to make it, I guess, clearer for you guys. So then you group. So this is like from the example, gene 1, gene 2, gene 3, gene 4, right? You group them out together, and then you also keep grouping them together, right, until you get the last one. So basically, you kind of would choose the splitting position to be probably something at this position right here, right? And then it will in turns get you group 1 and the 1 and 3 together, and 2 and 4 together. Good. And in terms of data, like you can like kind of see the data. You can see like if the data spread out something like this. Right? Right? You would then try to see. You would then pick a point, and then choose another point that is closest to them, and group them up together. So for example, if you look at this point, I'm gonna say that this group are kind of at the same position. So then also go with maybe this one, right? And same thing with the rest. So I'll go with this. Just find another one that is closest. So maybe I'll go with, oops, here, and last one is here, right? You finish the first grouping, and then you will keep repeating. So then you find that this group is also close to this group. So then you group them out together like here, and then you pick these two. There are 3 clusters, so you only pick 2. So then you go with probably maybe I decide to use this one, and then you repeat it again, and then you see that this green is similar to is close to the blue. So you just go with. I feel like I'm gonna run out of color. Anyway, this purple, right? And then you keep doing again. So you're gonna group the red and purple together to be this one big, right? But you don't want to use this dark blue and say that this is going to be your best cluster, because it basically says that this group is also the same group as this, right? So you want to find a chopping point. So like here, you want to find a chopping point to separate the data together. So you can go with probably this, and then you're gonna say that now it's separated to these two groups, which is this one and then this one. But it also depends on your choice. You can also go beyond to be something like this to group it into four, like this one and these four are together and these two are together as a fourth one. So you have 1, 2, 3, 4 groups. So basically, yes, this is another algorithm to do the unsupervised learning, which is to group them together. How do you group it together? Basically, find the closest point to each data point and keep grouping them up, and then find a stopping point. Again, you don't have to memorize. I just want to show the different ways that you can do the grouping. And yeah, there are some terminologies that might come up. So once you finish grouping the data together, if you have a new test of data, right? So like say this gray one, how do you choose what's gonna be the criteria for you to choose uh, which data how the data belongs to? So there are three. Could go with another example to see if this works better. Maybe this and this. Not deleted. Suppose there are this green and blue. So there are three ways. If you have supposedly you have a new data, which is this black one, right? You can use there are three properties from the cluster that you can use for it as a comparison on which class should the test data belongs to. You have uh, the basically the center position of the cluster, which is we call it centroid, or you can find the closest point, which is something called the single linkage or the furthest point, which is complete linkage. So for example, let's look at the centroid first, right? So you can see that this group has a centroid as this position, and this group, the blue one, has a centroid of this, right? So basically you have a distance of this and this, and you would go with the closest one. So now if you assign the centroid, you're going to assign this one as green when you use the centroid, right?
Wait, how do you tell which color to assign it on based on, like, would you assign it based like either green or blue, or could it be only like one?
Yeah, for when you give in a new data, you kind of also want to group them together. So like this black one is like if you're talking about how do you assign the black one, so yeah, you just go with the see which position, which cluster it belongs to.
Mm-hmm.
But if you're talking about like how do you come up with this example, like you have these three and these three, then that's just something that come up for as an example. It could be different.
Oh yeah, I was just thinking. Okay, so because the thing that the black point is closer to the center of the green points, it would end up becoming green.
Right.
Okay,
Exactly.
okay, thank you.
Yep. And that's when we use the centroid, right? And then when there's also another part, which is you find the closest point in each cluster. So let me also technically adjust the position a little bit to make it works for you for this position. Right, so we have centroid, and then the next one is a single linkage, which is the closest point for the cluster. So what's the closest point from the black to the green? So it's gonna be this one, and closest one is gonna be to the blue. So it's this one, right? So you're gonna see that the distance from the black to the closest blue the distance is shorter than from the black to the green, right? So in this case, you're gonna assign this position as this new test data as a blue, right? When you use closest, the closest data point, right? And lastly, there's also some, you can use something which is called complete linkage, and that's the furthest point in each cluster. So you're gonna compare, again, you keep doing the finding the furthest point. So supposedly it's this one, right? And the furthest point for the blue is gonna be this, right? It's not good here, right? So this, you can see the distance to the green is shorter than blue. So then you basically assign this point as a green cluster. So it's gonna be green when you use the your furthest data point. Furthest, right? So this is to recap this. We can, there are different ways that you can try to classify the data when you already create a group. You can use the centroid. You can use single linkage, which is the the closest point, or the complete linkage, which is the furthest point. And different criteria could give you a different result, but that might be become parts of your decision to choose that which one could works for your data. Then there, I don't think there's like a ideal solution, because depends on how the data clustering looks like, and also how depends on how like the test data looks like as well. Because and I think I kind of want to explain one, but that's probably too much detail, and I don't think I can like also fully explain it to the concept. But just take it as a surface level, that there are different ways that you can like assign the data to the center. Yeah, you're going to compare it with either the distance from the data to the center, or the distance from data to the closest point, or the data to the closest point, or the data to the furthest point. It all depends on how you can decide. Clear? Cool. And then otherwise I'll work on this last algorithm, which is something called DB scan. And this is going to be last algorithm, and then we'll take a break and maybe do the office hours, all right? So please bear with me. So for this algorithm, we're going to call DB scan, and let's in short, for the requirement for this algorithm is that you first have to specify, there are two things, radius and minimum point. So minimum points. And the way it works is you're gonna specify the radius, and you're gonna specify minimum points. So each point in here, you're gonna have its own radius, right? So you're gonna, and when you have specified a radius, in this case, they use it as epsilon, but I'll probably write down as English so that this is easier to understand, right? So you specify the radius, and then you basically draw a circle. And for each data point, you draw a circle, right? And then you see that there's gonna be some criteria like if there are points that are greater than or equal to minimum, then let me see. I want to, I'll write down the English. If there are points, or in this case data, greater than or equal to the minimum point, then we're gonna assign it, assign that point. So which is this one. So we're gonna have, so let's work on this one first, right? We're gonna assign that one as core data plot. Right? But there's also another case, which is if there are points of data and it is, should go with here. If there are at least one and it's below the threshold, which is the minimum point, we can assign them as border. But technically it should be greater than one. But lastly, last criteria we have not that. Yeah, I'll write down the criteria first, and then we work on the example to see how it works. And last criteria is that we want to see if there's any points or data that is equal to 1. Then assign it as a noise. So let's see how it works, right? So supposedly you assign the radius to be like, I don't know, 2, maybe like 2 units, right? And then minimum point, in this case, we assign it 4, right? So let's look at this this red one. Should go with this blue, right? So you basically goes along this radius and you draw some kind of radius. So go with R, right? So you're gonna draw the circle around it, and within its circumference, you'll count how many points are there within its own area, right? So there's the first one, second one, third one, which is also included itself, and fourth one, right? Maybe this one, but it's okay. This four already enough. And then you come back and look into here and see that which category this point belongs to. So if there are points that are greater than minimum point, which is greater than or equal to 4, you assign it as a core. Right? So you basically assign that superposition as a core, and then this is gonna be the red. We represent it as a red color, right? But if you look into another data, which is this yellow one, and you again draw a circle around it, and look inside its own area and see that how many points are there. This is cell, which is 1, and then another one is here, 2, right? So there are 2. So then you say there are 2, 1. So 2 is between 1 and 4, right? So you assigned it as a border, which is we represent in this example as a yellow one. And last case, which is you have this data point. Again, draw with our radius, draw with the radius, and then draw a circle, and count how many points are there within its area. You can see that that's only 1, which is itself. So when it's 1, then you basically assign that data point as a noise. So which is represented with the purple. And now you would get that something that looks like this. And basically from this algorithm, you can kind of see that the purples are just a noise data or outliers in this case, and these purple are outliers. And the red and yellow are basically, they are in the same group, right? So if you try to filter out the blue, red, purple circle, then you're gonna get should use highlight. You're gonna get that these belong to the same group, same cluster, while the purple are just a noise data. So you can see that the algorithm for DB scan is that the advantage of it is it will classify the noise for us. Hopefully, if you specify the radius and minimum point correctly, it will basically group them up together and also remove out the any outliers, or basically this one is a noise, and you will remove out from the border instead of include them as within the same board, within the same group or same cluster. Question with this? And I believe Professor might put that on, or I can pull up from here. Yeah, it will look something like this. If you, when you compare when you're using the DB scan and the k-means clustering, which is the first one that we just learned, right? If you specify the DB scan parameters correctly, which is like the minimum points and the radius, it's gonna cluster the data all together, while there are some like noise or grouping the another group in like the hopefully the better. Well, that's better is subjective, but yeah, a better grouping and cluster rather than you use the k-means, right? And then you split like into 3, something like this. But you can like DB scan, hopefully that will work better for you. And the same thing is this second example. Right? Basically, the ones that are grouped together, then we'll basically specify them as a group together, because same thing, you keep drawing the circular, right? The circle around yourself, it's gonna look something like this. There's gonna be like a millions of the circle, you keep drawing and then find a minimum point, right? And then you basically group them up together. But if you use k-mean, it may somehow split the data into something like this, which is not the one that we want. So like in the short term, DB scan kind of reduce the noise and then maybe grouping the data in a better sense than k-means at some situation. But yeah, that's just how people come up with algorithm to grouping the data all together. I don't think that's like an ideal solution, but that's just something for you to be aware of, that when say like, oh, if you have a data without label, that's basically falls under the unsupervised learning. But how do you classify the data then if you don't have a label? Basically, you have all these algorithm, k-means clustering, you find the means, shifting again and again until you converge it, and then you're grouping them up together. You have hierarchical clustering, you're grouping this similar data together, and then you basically find a cutting point, right? And the last one, which is DB scan, you specify radius and minimum point, and then grouping them up together. Question? Comment? Concern? Or is it all okay? Good? Yeah, I guess it's a long day because yeah, we have lecture and guest lecture. Yep. If you guys don't have any question, let me see. Is there anything that you guys want me to go over the homework 3, or if there is not, then I'll probably just call it a day and turn this into office hour. But yeah, I don't think for the recording part, I think that's pretty much it for this lecture. Hit subscribe. Anyway, I'll stop the recording, and if you guys have questions, also feel free to put on PSR and email me or anything. Yeah, I'll stop recording.